Here I will show you how to work with the basics of LoveCC, Love2D emulator for computercraft I wrote. This is gonna cover how to install it and make a basic program with it. It is pretty similar to how Love2D works, so if you are familiar with it, it should be pretty straightforward. So let's start with the installation. You need to get a link to the GitHub repository, and then you need to use git to clone it. So I can just open a terminal, and I can pretty much just git. Oh god, this is terrible. Hold on. Git clone and the address. Yeah, now that it's done, I have it installed. After that, you just need to move the Love2D file out of the folder, like this. To start off with your game, or the program that we are gonna be making, you just need to make a new folder with your game name. And there you need to make a main.lua file, like you would with LoveCC normal, Love2D normally. So I can just edit game/main.lua and just do that. Let me just refresh this so I can see the file. Huh. No? Bruh. Oh my god. Okay. That was dumb. I made a game. Now I make a main.lua folder in it. Right now, if I run the program, it will not do anything. No game. I can also do love and your folder name, and it will not do anything because it's empty. So what I'm going to do, I will make a simple program that will just show a gradient from the left to right. So for that, I will need to use the love.draw callback, like you would with Love2D normally. Wait, fuck. Draw. Okay. Now, since I wanted to resize with the screen, I can just grab the size using this Love graphics get dimensions. Okay, now I will need to make the covers of the gradient for the entire screen. So I will just add a for loop that will iterate from 1 to v, which is the width of the screen. There. Also, I will need to have the amount of change it will make each pixel, so it actually can change like a gradient. So I can easily calculate it using change equals 1 divided by width. 1 is the maximum cover value, and width is just, you know, the width of the screen. So now we have basically the amount of cover change that will appear each pixel. Now I just need to calculate the cover back, so I can just select local cover equals change times I. Yeah, I think that should work. After that, all I have to do is just draw a new rectangle, so it's not just really thin, so we have it over the entire screen. Love graphics rectangle, and we want it to be filled, and we want it to be on the X position will be I, because that's, you know, how it's gonna move. The Y will be 1 because I want it to just be up there, and then width is gonna be 1 and height is gonna be height. Okay, now I just need to set the cover, so love graphics set cover. So it's basically just gray, and this should be fully working now. Yeah, as you can see, it doesn't look very nice because in computercraft you only have 16 colors, and these are the ones it finds closest to what the gradient is supposed to be. But as you can see, the scaling works really well. first try. To fix this, the first thing you can do is enable quantization, which will select the best palette for the current frame, which you can do using Love.cc .quantize true. This will already get us a huge improvement in the clarity. Yeah, as you can see, it is much better, but it's still limited to the 16 colors. To make your eyes think it is more than that actually is, you can just do LoveCC.data, which will enable dithering to make it look better. Right now, as you can see, it looks a lot better. And it scales too. So it still works like the original, just looks much better. Also, for error handling, if for example we say that an error happens here, that is gonna be a nice error screen which will just tell you what happened. Also, there are other things implemented like threads, which you can use, and there is also other callbacks like thread error. Let's show that. Let me just local thread equals love thread new thread, and you just pass the string of the function into here. So I will just have this error, and now I will have to load the thread, so I can just do, I mean what? No, there. And now, actually let me just have it taken the message that we give it, like this. And now I can just do a callback, the thread error callback, which gets the thread and the message. And then I can just make the string to be error in thread thread there I'm the message, the error message. And now I can just print that. Of course I don't have to save this like it, but it's more nicer when I have this small window. And now if I run this, as you can see, it prints it nicely that it's a thread error. I can also change the message. Yeah, there is also other things like love.quit. So if I try to quit, it will remind me that I tried to quit. So I can just error try to quit. And now if I try to terminate it, it will error. And of course it doesn't fix the palette since it quitted before it had a chance to. Now what I can do, I can just do return true, and now it won't quit. So if I try to terminate, it doesn't do anything. I have to reboot. What I could do is I could just disable dithering for a bit so it's visible that it actually stopped. Yeah, when I try to terminate it, I would just disable dithering. And now when I try to terminate it, it will just change the dither mode. Yeah, that works well. There is a lot of callbacks, pretty much all of the interaction ones in Love are implemented, so I can just do mouse moved. And now I will be able to just show a line from where the mouse from the center to the middle. That's gonna be pretty nice. So actually this is not necessary, but I'm going to use it anyway. So just I can do local x equals 0, local y equals 0. Now I can just do this, and now I can, this is unnecessary, you don't even have to use the callback here, but it shows how it works pretty nicely. Now I will have to calculate the center of the screen, so I have to get the width and height. Now I have to calculate the centers. There. And now all that's left is to draw the line. So I'm going to set the cover of the line to 1, 1.8, 1.8.4. This should be yellow. And I'm going to draw a line from XY, which is our mouse position, to the center X and center Y. And I think this should be correct. Also, this line is probably gonna be like really thin, so that's not good. Oh, I also have to reboot because I had the laptop quit. Yeah, now we have this line that follows our finger. I can also just resize it and it will automatically adjust, so that's nice. I can also change the point size, so I can do Love2D graphics set line width, not point size, sorry. And now, yeah, it works. One cool thing I can also do is I can render text on top of it. So I can like draw the FPS. Let me just take this and I'm going to draw it completely white but half transparent. So now when I type print, I will print FPS love timer get FPS. And now I'm going to print it. I have to calculate the center, but I won't do that now. That's not. I'm just going to print it at 1 1 or something, 10 10, so it's a bit more visible. Yeah, now I have this, and as you can see, it actually is transparent. It gets more yellow when it's over it. Also, there is some artifacting, but there is nothing I can do about it because of how I handle the graphics using special SCI characters. Also, I can add it so I can scale this line just by scrolling. That's easy. We can just do local width equals 5, math ABS width, so it doesn't break when it goes negative. And the last thing I have to do is function wheel moved direction X, direction Y, and I can just do width equals width plus direction Y, and this should be enough for it to work. Oh, well, it does not work. That's disappointing. Does this even get code? Oh, it does. So the callback works. Oh, I see. I know I said it once. My bad. I have to move this to graphics.update. Now it works. I can also just increase the screen size. And it scales nicely. Yeah. The text is fully transparent. As you can see, it works really well. I can also make it more transparent. And it will... Wait, wrong value. And it will be just more grayish in general, but when I cover it, it will be even less visible. Also, if I make this like red, it will be quite visible that it actually gets red when it's under it. You normally can't easily do this. Also, as you can see, it can be quite stuttery, but if I disable quantization and deterring, it gets quite crappy, but runs a bit faster. You don't have to actually deter, you can just run quantization, which in itself slows it down quite exponentially, but it fixes these issues. Dithering is not really needed unless you have more than 16 covers. Also, the quantization is quite fast if you just have less than 16 covers. I'm gonna be something else that I should show you. Yeah, I think that's it for now. If you watch till here, have a nice day and bye.